Robust real-time multi-target tracking is an active area of research. We tried using existing algorithms that scored at the top of the single object or multi-object tracking benchmarks. Even the longer videos among them look qualitatively very different from typical TV and film scenes. So we manually annotated 2 very long videos that do represent our filming scenarios. Scores for those algorithms and our own new tracker are in the paper. The main finding is that some tracking mishaps are worse than others. For example, latching onto a distractor is worse than reporting loss of track because it jerks the camera away, ruining the whole take, shown here with a red dot. Lighting conditions, occlusions, and distractors make it especially hard to film around other people. The unknown tracker used commercially in DJI's Osmo Mobile 3 needed 7 takes to get the sequence right, when ours worked both times that we tried it. Of course, the tracking feeds a control loop, which also plays an important role. By following the raw tracks, the footage on the left looks unpleasant and shaky. Through our controller's adaptive filtering of the tracks, the same scene looks much better while remaining responsive, on the right. And shakiness becomes an optional attribute rather than a constant nuisance. We report gimbal velocities for this scene here and in the paper. Here we test leniency closely in a controlled manner. At first, LookOut instructs the camera to follow the actress closely, reacting to every move. With more leniency, illustrated here with the ellipse, LookOut is agnostic to movements as long as they remain close where the actress should be in frame. If the actress drifts too far away, then LookOut pans the camera to compensate. Good tracking and smooth control are the cornerstones of the LookOut system. We used the same tuning settings and found that they worked the vast majority of the time. But the real question is, what did filmmakers think? We designed and ran a small 5-person 50-minute field study with an earlier prototype to test the whole premise of LookOut end to end. Users were given this storyboard and direction over 2 actors in a local park in the late afternoon. 4 of the users tried LookOut, while 1 control user filmed the same action, just using the default stabilizing gimbal. The user in the control condition needed multiple attempts, but was, eventually, able to get this as their best take. In their experience, it was always hard to get a nice low shot, using the joystick or otherwise. Broadly, the camera movements are smooth, but the framing suffers, especially near the end of the take. The LookOut users spent 15 to 25 minutes on a park bench with a laptop, learning the LookOut GUI and building a script to match the storyboard. They all easily succeeded in this task. In the remaining 15 to 25 minutes, 2 of the 4 participants had enough time to record a long take that they were happy with. For the other 2 users, the main problem was that the natural light was uncharacteristically bad, hurting the detector. Apart from concerns about tracking brittleness, the feedback was mostly positive. Users liked the smooth and assisted motion and suggested other scenes they would like to film with LookOut. We interviewed 3 experienced filmmakers, distinct from those who influenced our design and from those in the end-to-end pilot. Each one was prompted with the same set of questions, and then watched videos A, B, and C while thinking aloud. The prompt questions got them to, first, explain what equipment and people they would use normally, and second, to critique the footage and capabilities of LookOut. They all said that with only 1 extra helper, that person would be the spotter guiding the operator. 2 of them have used drones, and could use them here for the outdoor parts, given budget for a pilot and leniency on noise. For video A, 1 would clear a track through the rocks, and 2 would use cranes and split the take into segments. 1 complained, however, that cranes have badly placed viewfinders, resulting in them shooting blindly. For videos B and C, 1 said he would use a Steadicam, and the other 2 named specific 2 or one-handed gimbals, like the one modified for LookOut. The feedback on LookOut itself was very positive. 2 filmmakers spontaneously started thinking up new opportunities for shots. The explicit concerns were that A, LookOut would have no place in a big budget project, And B, like adoption of drones, they would need to use LookOut multiple times before they'd trust it.